Hello. The following Boston Centerless video illustrates the impact of straightness on Swiss operations. Specifically, how straightness dictates the amount of operator involvement needed to keep your Swiss machines running well, how it impacts your end product in terms of your dimensional capability, and lastly, how it impacts the overall cost efficiency of the entire manufacturing process. Here you'll see a basic schematic of a Swiss machine. In the Swiss, the material rides inside the guide bushing as it feeds through to the actual cutting operations. It is the bar straightness that significantly influences your ability to hit your production speeds and throughput, as well as hold finished dimensions. Before we look at the bar straightness in detail, realize it acts just like an out-of-balance tire on your car. At some point, the out-of-balance frequency matches the natural frequency of the car and they become additive. When this happens, you get the telltale steering wheel shimmy. Let's look at two examples of how straightness impacts a Swiss machine. First, let's assume you've set up the machine and you begin to ramp up your material speeds. As the bar RPMs increase, so does the vibration frequency, which is set up by the out-of-straight bar. At some point, depending on the material speeds and the actual machine configuration, the vibration frequency matches the machine's natural frequency and the machine starts to shimmy. Unfortunately, it's not as easy to detect as that of a steering wheel. It typically shows itself in out-of-spec parts. When this happens, the operator now has two choices. He can slow down the machine to keep the vibration frequency away from the machine's natural frequency, or he can continue operations, potentially speeding up the material to get past the machine's natural frequency. But doing so, he runs the risk of making bad parts which may later need sorting. In either case, your costs increase. The second example occurs when you are machining an out-of-straight bar. The tool is continuously cutting varying amounts of material as the bar rotates. When this happens, the tool stress significantly changes as the bar rotates. In this case, the tool sees changing bending and contact stresses. Now, understand that tool life is inversely proportional to the contact stress to the 9th power. What this means is any small changes in stress has a huge impact on tool life, either good or bad. This drives tool maintenance costs up, but more costly than that is the impact of taking the machine down to replace the tool or the insert. At $150 to $200 per hour, it adds up and can quickly negate any price savings from buying cheaper material. To learn more about this topic, visit our website for a more in-depth video on this subject or schedule a lunch and learn presentation. Thank you for watching, and we appreciate your business.